Hi everyone, we are Period 1, Group 7, and in today's podcast we will be talking about real gases. To understand real gases, we must first understand ideal gas. An ideal gas demonstrates the behavior approached by real gases under certain conditions. However, there are two incorrect assumptions in the ideal gas law. They assume that there will be no particle interaction and zero volume. Although the equation PV equals nRT is generally pretty useful, in cases where chemists need to be more precise, they use the van der Waals equation. This equation makes a correction for the volume and a correction for a pressure for a real gas. The correction for volume is necessary as the actual volume of the molecules themselves in a real gas takes up some of the volume and space of the container. We can correct the volume by considering the number of particles and the actual volume of the individual molecules. The actual volume of the individual molecules is represented by the letter B. Thus, to determine the volume for a real gas, we subtract NB from the volume of the container. So rather than using a V, we use V minus NB. The correction for pressure is necessary as the molecules in a real gas do indeed interact. Correction of pressure is made by considering two factors: the ratio of the number of particles and the volume of the container, and the IMFs. The more concentrated the particles, the more collisions there will be. And since different molecules have different IMFs, the larger and polar molecules tend to have stronger IMFs. By combining these two corrections, we get the van der Waals equation. P plus A times the quantity of N over V squared times the quantity of V minus NB equals nRT. The A in the equation represents the correction made for the pressure, which is based on experimental evidence for each gas. And V minus NB is the correction made for the volume. Gases behave more ideally in high temperatures and low pressures, because in high temperatures the IMFs decrease, and in low pressures the molecules are so spread out that they rarely collide with each other.